Okay, so for lab 7, frequency response of RLC components. So for this one, we will use these equations. XL reactance of an inductor equals 2 pi FL. XC equals 1 over 2 pi FC. Then for sine wave, Vrms equals 0.707 Vm. We know that's the Vm divided by square root of 2. VPP peak to peak value equals 2 Vm. Okay. So for the first part, part 1, this is for a resistor. So resistor connect to a function generator. Then we will change the frequency and make sure voltage across the resistor VR is the 4 volt peak to peak value. Then we need to insert an ammeter, then we can measure the current. So, however, we know there's no AC current meter, ammeter in Tinkercad. In Tinkercad, the current meter what can only measure DC current. So actually, so for part 1, we cannot do it. So we just skip part 1 again. So we don't do part 1. So part 1 actually very simple. Just change frequency, make sure peak to peak value VR keep us the 4. Then measure RMS and also use Ohm's law calculate the resistance. Then compare with this value. So again, so we don't do the part 1, okay, because there's no AC ammeter in the Tinkercad. We start from the part 2, okay, part 2 inductor. So for this one, this is like we did before, resistor RS. This is the sensoring resistor. Connect to an inductor in series. So in series. So this is a series circuit. Function generator. So this is the frequency start from the 10 kilohertz. Okay. Resistance use 102.4. Similarly, so also similarly to the circuit the lab we did before, adjust the magnitude of the function generator and keep the VL is the 4 volt peak to peak value. So we use this one, peak to peak value. So for this one, the same. In real lab, we will use a DMM, digital multimeter, measure the voltage across the RS. So that's the VRS. And we know VRS actually is the RMS value, root mean square. Then we need to do the calculation, convert RM's value to peak value. So this one, so peak to peak value, then use the Ohm's law, get the current with the different frequency. Okay. In Tinkercad, so we know there's no AC voltmeter. So we have to use the oscilloscope, measure the RS, the VRS directly. So let's do this first. So go to Tinkercad, open this one, create a new design. Okay. So let me change the name first. So then change change this to all. First, breadboard. Then function generator, we need the function generator. Okay, then connect the function generator, the positive terminal to the breadboard. So this is positive, then positive to positive. So these two red power lines are connected. Then negative. This is a negative. Okay, so I need to change this back to red. Okay, so now power line are connected. Let me double check. Positive, positive, negative, negative. Okay. Then we need a resistor. So we could put this way across the sections. So I think I don't remember the number. So let me go back. So 100 and 2.4. Okay. So this color code, so brown, black, brown. So this is 1, 0, 1, right? This. Then the last one, inductor. So we can go this way. So this is the 1 millihenry. Okay, let me double check. Yeah, 1 millihenry. Okay. Then the last one, so we need the 2 oscilloscope. Oh no, we need to connect. So this goes to negative. Then this one go to positive. So change to green. Okay. So positive go to resistor, then go to inductor, then go to ground or negative. Okay. Then the last one, so we need the oscilloscope. So we need the 2 oscilloscope. So 1, 2, go up a little bit. Then click this button for feed. Okay. Okay, so change to red. Then this one, so left oscilloscope will measure the voltage across the, let's go down here. Across the resistor. Okay. Then this one, so go to this point. Okay. So I said before, we could not do this in the real lab. This because for real lab, the oscilloscope, the negative terminal, that's for ground, connected ground. So actually they are connected. In simulation, we can do this. Okay. Okay, just go here. Then negative, so just go to ground. Okay, change this to black. And this also is black. Okay, let me adjust a little bit. Okay, so now we can start now. So at the beginning is the 10 kilohertz, if my memory is correct. Yes, so I just do 2, so 10 kilohertz and 30 kilohertz. So make sure voltage across the inductor is the 4 volt. Okay, let me do this way. Okay. Okay, so at the beginning, this is the 10 kilohertz. So I need one more zero. Then start from maybe start from 2, let me 3 first. So 3 we know is not enough. So just start. So not square wave, sine wave. Then change the setting for this one. This is 10 kilohertz. Then we need to go to mu. Okay, so we got. Then still to nine. Go to 10. Okay, 10 is good. So we can go to 20. Okay, so this one also change it to 20 millisecond. Okay, so this is the setting for this one. So you can see, let me make bigger. Okay, so this is just the 2, so 2 volt. So we need to increase this. Oh, offset should be 0. I forgot to change this. So this is the reason why this jumped. So this is, so let me change it to 4 first. 4, so you can see this is the 4 volt from top to the bottom, right? So this means this is less than 4. I actually just around 2. So let me double, maybe go to 7 first. 7 still not enough. Go to 8. Okay, 8 is good. So 8, so now the setting for this one is the 10 volt. So you can see 10 volt from top to the bottom. We know in vertical direction, total is the 10 divisions. Then this means for one vertical division is 1 volt for per division. Then for this one from top to the bottom, so 1, 2, 3, 4, so 4 divisions. So this is just the 4 volt peak to peak value, 4 volt to peak to peak value. So we got this. So VL, this is the 10 kilohertz, the 4 volt peak to peak value. Next, we need to measure VRS, peak to peak value. Okay, so for this one, so this is RS. Then, okay, so we need to count the vertical. So we need to count vertical divisions from the top to the bottom. So this may be 0.2. So 1.2, 2.2, 3.2. So actually we know this is symmetric with this line, right? So total should be 6.4. So let's keep going. So 4.2, 5.2, then 6, another 0.2. So totally 6.4 divisions. So this is VRS, peak to peak value. Then this is the setting is also the 10 volts in vertical. So this means it's 1 volt per division. Then times 1 volt per division. Then peak to peak value. So we know it's 6.4 volt. Okay, so go to the handout. So we can write down here. So this is 6.4 volt. Then we can calculation. So I current peak to peak value. So it's VRS peak to peak value divided by RS. So we can use the calculation. So 6.4 divided by 100, 0.2, no, 102.4. So then we got is 0.0625 ampere. So we know if we move this point to right by 3 digits, so we know this is 62.5 milliampere, right? So we can write down this one. So 0.0625 ampere. Then XL. So XL, so match the value. So this from the current. So that's the VL peak to peak value divided by I peak to value. We just got. So we know this is the 4, right? So 4 volt. So 4 divided by 0.0625. So this is 64. So 64 ohm. So this. So XL 64 ohm. Then this is the calculated value. So XL equals 2 pi F L. Okay. So then we can use the calculator again. 2 times pi times frequency is the 10 kilohertz. Then times the inductance is the 1 millihenry. Oops. Okay. So 62.8. Okay, so maybe close, right? So 62.8. Oh, so maybe close. So this means our measurement is correct. Then keep going. So last, we need to adjust the frequency to 30 kilohertz and keep VL peak to value still is 4. Okay, so let me do this. Erase this first. Okay, so when we change the frequency, so we know actually the XL should be changed. We said before XL is proportional to the frequency, right? So go to 30. Okay, so the setting here, the better. We also change this setting. This is maybe go to 2. 2 is too small, so 5. Okay, 5 is okay. So this also change it to 5. Okay, so now for this one, the setting here still is 10. So this means it's the 1 volt per division. So totally for the BL, so now we know greater than the 6 divisions. So that means around 6. So this means the voltage here, source voltage is too large. Let me change it to 6. Let me check. Still large. So we just need the peak to peak value is the 4 divisions. So keep decrease. This is still need to change, maybe 4.8. Okay, 4.8 is okay. So now this is the 4 divisions in vertical direction from top to the bottom, right? So 1, 2, 3, 4. Okay, so we got this one. Then check the VRS. Okay, so this one, so maybe 0.8 or 0.9. So let's use 0.9. So then 1.9, 2.9, 3.9, 4.9, another one. So this is 4.9 plus 0.9. So we get the 5.8 divisions. So VRS peak to peak. Then the setting, so now it's the 4 volts from the top to the bottom. totally, this is the 10 divisions. So this means the setting for this oscilloscope is 0.4 volt per division. Okay. Then for multiplications, the result so is 2.4. Let me double check 2.4 volts. So 5.8 times 0.4. Oh, 2.32. Okay, I did wrong. I think it's 5. Sorry. Yeah, 2.32. Yeah, 4 times 8 is 32, right? Okay, so this is the VRS. Then go back to handout, so 2.32. So write it down here, 2.32 volt. Okay. Then again, do division, get the current. So 2.32 divided by 100 and 2.4. So we got 0.0227, round to 3 digits. Okay, ampere. Then we can use the 4 divided by this number, right? 4 divided by, so use parentheses. So now it's 176.55, so maybe 6. Oh, okay. So this from the measurement. Then from the calculation, so we use the 2 pi f. 2 times pi times f, 30 kilo, then times 1 millihenry. So 188.50. So still close, right? So very close. Okay, so you just keep like this. So change the frequency, then make sure VL is the 4 volt. Then measure VRS peak to peak value from the left of the scope. Then calculate the current, then get the XL, the reactance of the inductor, and then compare with the calculated value. So after finish this one, then we need the HD mark these points. I mark this value in a figure. Okay. So just here. Okay. So you can see this is the figure horizontal axis from the 0 to 100 kilohertz. The vertical, so this is for XL in kilo ohm, okay. Then from 0 to 10. Then we just get the 2 values, right? We know bottom one, this is 100 and 76.6 ohm. So this is in 10 kilohertz. So it's from this line. So we need to mark this point in this figure. So let me draw a line first. Okay. So this is the 10 kilohertz, right? So we need to draw a vertical line, go up. Actually, we're not so high. Okay. This is okay. Then this is the 176.6. So this is 100.1 kilo ohm, just 100. Then for each small division is 0.02 as the 20 ohm. So then let me mark here. So then this is 100, 20, 40, 60, 80, then this is 80, 76, almost in the middle between these 2 points, right? So we need now we can draw a line. So for you, the better use ruler. Okay. Okay. Then we got the intersection point. So intersection point is at this position, right? So we can cross here. So this is the first point. Okay. Then second point, so it's 30 kilohertz. So it's here. The same. Draw a vertical line first. Then go up. I did something wrong. Sorry, I did something wrong. Okay. Actually, I did something wrong. Sorry, this number is for the 30 kilohertz. Okay, this for the 30. This is for the 10 kilohertz. Okay, so let me redo this one. Erase first. Oh, actually, I can keep this. Okay, so let me go to 176 first. Okay, almost this position. Okay, so this is the 176. 10 kilohertz is 64. Okay. So from here, oh, this is not good. Let me still use a line. Okay, so this is 64. So 64, so 20, 40, 60, 64, close to 60. Okay. Yeah, almost here. So this is the first one. Okay, so this is the first one. Then remaining, so then you can get other number 50, maybe 50, 60. I think the last one is 100. Let me double check. Oh, 10, 30, 50, 70, 100. So totally, okay, let me just go to this position. So then 50, 70, 100. So totally you will get the 5 points on this figure. After you finish mark these 5 points, then collect them, so should be very close to a straight line. Because XL we know is proportional to the frequency, right? So this is for this step. Then the last one, so for after you get this line, then you need to get 15 kilohertz. Then use this plot, this figure. So we need to get XL when frequency is 15 kilohertz. So same. So go to this figure. This is the 15. Draw a vertical line until you reach that line. Then go to your left until reach the XL. So you will get the value of the XL, right? Then for calculated value L, so we know here, already here. So XL equals 2 pi FL. So L equals XL over 2 pi F. So you can get a value here. The nameplate value, so that's the nominal value. So just use 1 millihenry. So it's this one. Then this is for compare. Then when you finish the inductor, so you need to go to the capacitor RL, the same one. Similarly, so adjust the frequency. This is the frequency from 100 Hertz to 2 kilohertz. And also make sure VC is the 4 volt peak to peak value. Okay. Then measure the VRS. This is one, the same one, VRS peak to peak value. Then calculate current. Then get the XC, that's the VC divided by current. Then also compare with the nominal value. So C is the 0.1 μF, microfarads. Okay. Also, when you finish this, mark the points in this figure, so you should get a curve, hyperbolic curve. Okay. Okay, this is the similar one. You need to get the XC at the 650 Hertz. Okay, so then get the C, use this formula. C equals 1 over 2 pi F C. Okay. Okay, so again, so for this lab, just do part 2 and part 3. Yeah, we don't do part 1 because we don't have the AC and meter in Tinkercad. Okay, so just do part 2 and part 3. Okay, so you can start now.